So here is another question on relative velocity. So here it has been given that two trains, each of length 100 meter, are running on parallel tracks. Okay. In one case, one of the train overtakes the other in 20 seconds, and in another case, one of the trains it crosses the other in 10 seconds. Calculate the velocity of each train. So here this question can be divided into two parts, and please pay attention to the words overtakes and crosses, okay, because it will give us information about the uh, direction of the movement of the trains, okay. So here let's consider first the overtake, case 1, okay. So the train is overtaking, it means let's say there are two trains, okay. Okay, let's say this is moving in this direction with velocity, let's say v, okay, and here another train is moving, let's say, with velocity v. So here this is v, this is u, sorry, this is u, sorry, this is v, this is u. So here naturally you can see u is greater than v, okay, and this train with velocity u is overtaking it. So here let us understand what this overtaking process means. Overtaking means this entire train with this, the last bogie of it completely crosses this point, okay, this point. So let's say the train here, it started here, okay, this is the first train, and the overtaking process started here, the first train, okay, like this. This is the position of the last bogie. Then this train it reached this position, okay, let us this train it reached this position here, then it crossed by this position, this much, okay. So the total distance that this train has covered, okay, the total distance that the train has covered is twice the length of itself, because both of them are of equal lengths, 100 meters. Both of them are of equal lengths. This here. Both of them are of equal lengths, 100 meters and 100 meters. So total distance covered is equal to 200 meters, okay. And here also the concept of relative velocity comes into play, okay, relative velocity it comes into play. So here relative velocity of both the trains which are moving in the same direction is equal to u minus v, okay, u minus v. So let us keep the units in meters per second, because the distance here it is given in meters, time is in seconds. So it is u minus v. So here the time of overtaking will be equal to distance by time. So it is 200 by u minus v, which is given as 20 seconds. Okay, 20 seconds, that is given. This is the first part, the first case, the first equation. Then we have in the second case, case 2. The trains cross each other. So here the cross means that both the trains, they are moving in opposite directions. The same trains, they are moving in opposite directions. Okay, let's say this is moving with V, and we have another train, the same train, which is moving in the opposite direction. This with u, okay, v meters per second, u meters per second. So here also the crossing process will be over when this last bogie of each of the train, the one which crossing, it completely crosses the last bogie of the first train. So here both of them same lengths, so the total distance covered, it will be equal to the same 200 meters. Okay, 100 meters plus 100 meters, which is equal to 200 meters. Okay, and here the relative velocity, because both the trains are moving in the same direction, the relative velocity will be equal to u plus v meters per second. Okay, because they are moving in the same direction. Okay, so distance is 200 meters, relative velocity is u plus v. So here the time required for crossing is equal to distance 200 by u plus v. This is this much time, and that is given as 10 seconds. This is the second equation. So if you notice, see here in the first case the relative velocity is less in the denominator. So obviously the time taken was more, 20 seconds for the same distance. But here the relative velocity is more, u plus v, because the velocities are getting added together. As a result, the time taken is less, 10 seconds. So we'll be using these two equations to get the values of u and v. So 200 by u minus v is equal to 20. That implies 200 is equal to 20u minus 20v. Then 200 by u plus v is equal to 10. That implies 200 is equal to 10u plus 10v. Okay, this much. So we'll be solving them. So 20u minus 20v equals to 200, 10u plus 10v equals to 200. So we'll be multiplying this with 2. Okay, so the result will be, these will get cancelled, this will become 40u is equal to 600. I think this much, 40u is equal to 600. That implies u is equal to 600 by 40, yeah, it is 15 meters per second. U is equal to 15 meters per second, and v will become, using any one of these equations, so 10 into 15 plus 10v equals to 200. That implies 10v is equal to 200 minus 150, which is equal to 50. That implies V is equal to 5 meters per second. Okay, V is equal to 5 meters per second. This. So these are the two results that we wanted. So again, this question is very important. First of all, it was not given directly that the two trains are moving in the same direction or in the opposite direction. It was only given in one case, one of the train is overtaking it. It means both the trains are moving along the same direction and in parallel rails, and one of them is overtaking. And in another case, it was given that they are crossing each other, which means they are moving in the opposite direction, okay, and they are crossing each other. Both of them were of the same lengths, and here it was important to understand what will be the relative velocity between the trains when they are moving in the same direction, which was u minus v, and when they are moving in the opposite direction, what will be the relative velocity. Here direction plus minus was not that important. Here we are concerned only with the magnitude of the relative velocity, because we were asked to calculate the velocity of each train. Okay, so here we use the basic concepts of relative velocity to determine the velocity of each train. Okay.